Hello everyone, welcome back to Ocean Cafe. Today we are learning how to calculate the derivatives. In this video, I will show you the most fundamental that you need to know about differentiation, which start off with power rule. At the end of the video, I will show you examples which students often struggle to apply this method correctly. So what is derivative? Now, it is a term we often see in differentiation. So a derivative tells us how steep a graph is at a particular point. So in math language, right, we call it the gradient of tangent to the curve at that point. Now, this is a definition that all of us must need to take note because we will definitely need to use it, all right, later on. Yeah. So put it simply, derivative tells us how fast something is changing at that moment. Now, just for example, in this case, you see a point P here. Now, a derivative of the graph at this point P, it is simply the gradient of the tangent to this point. Yeah, so what you see here is, if I'm going to let dy that represent the small changes, all right, of the value of y, and I let dx represent the small changes, all right, of the value of x. So to find the derivative is simply the gradient formula, which is dy divided by dx, which is give us the derivative. All right, this is a very simple way of define. If you look into other theories, all right, it's much complicated. You tend to use the term delta x, delta y, which I am not going to cover in great detail in this lesson. Before we move on to power rule, let's understand the symbols and terms in differentiation. If we are given the function y, then the derivative, right, can be written as dy dx, which I have explained earlier on, or sometimes you can use y prime to represent the derivative. In some cases, if the function of the graph is given to be f of x, then the derivative simply, right, written as f prime of x. Now, we are going to find the derivatives, right, of some of the questions here. So let's understand the term. So the derivative, which I have already mentioned, right, this simply refer to, all right, the right hand side of this symbol here. Now, what does it mean when I say with respect to x? With respect to x, it simply means that, all right, the functions are all written in terms of x. So hence, therefore, you will see the function with respect to x. So therefore, the derivative also in terms of x. Now, there are some cases whereby not necessary with respect to x. What if I can have a situation whereby the function is written in terms of t, right? Then in such case, then the derivative will be written as f prime and in terms of t. This is something you need to take note, right? Which you will see at the end of the video here. Now, let's first start off with constant rule, all right? Now, constant rule simply means, right, if I give you these three examples, all right, what you see here is, in this case, these three functions, the values here, they are all constant, all right? So, constant rule simply means if I'm going to find the derivative, right, the derivative here, it will simply give us 0. Right, so any function that you see, as long as it's a constant value, when you differentiate, right, it will give you a 0. Likewise, for this exponential function, this is e to the power of 2026. All right, many students get confused here. Now, e to the power of 2026, it is not a variable, it is actually a constant number. All right, so therefore, when I find the derivative, this will also give us 0. So this is something very basic. So now we are ready to start the power rule. So this is a formula of power rule. Now what this simply means is that I have a function which is x to the power of n. So what I'm going to do is to find the derivative. All I need to do is I bring down the power, which is I bring down n to the front, right? So that means I bring down the power, and then after that, what I do is the power subtract by 1. All right, so I'm going to apply this rule to solve these 4 examples. So let's take a look at the first one. The first function here, I have f of x equals to x to the power of 10. So to find the derivative, what I'm going to do is I'm going to bring down the power, and then what I'm going to do is I'm going to take the power and then subtract by 1. So this will give me 10x to the power of 9. Now let's take a look at the second example. So for second example, to find the derivative, what I'm going to do is I'm going to rewrite this into index form. So this will give me x to the power of half. So this will give me, I bring down the power, which is half, and then power subtract by 1. So half subtract by 1. So this will give me negative half. Now the third example. So now to find the derivative, so again, I am going to rewrite this in index form. So this will give me x to the power of negative 1. So bringing down the power, I will have negative 1. And then the power I subtract by 1. So negative 1 minus of 1. So this will give me negative 2. So again, I don't just leave the answer as it is here. So what I need to do is I need to simplify this. And this will give me negative 1 over x squared. Now do take note of this. This is being tested very often. So you will need to see from 1 over x, how do you get the derivative to negative 1 over x squared very quickly, which later on I'm going to use this as well in the example. Now let's take a look at the last one here. So over here I have x to the power of negative 3. So again, to find the derivative, what I'm going to do here is I bring the power down, and then the power I subtract by 1. So negative 3 over 2, and I subtract by 1. This will give me negative 5 over 2. Now to make power rule more complete, let us look at two other rules over here that usually come together with power rule. Now the first one that we have here is called the scalar multiple rule. Now what is scalar? This alphabet here, this letter K, this represents the scalar. So can you see with the scalar here, and over here if I want to find the derivative, I just simply put the scalar outside. Now what is scalar? Scalar is also simply another word called constant. So what we are going to do here is we simply leave the constant alone when we differentiate. So we are going to differentiate these three examples over here. Alright, so again, I'm going to use power rule, right? So let's recall power rule simply, I bring down the power and power subtract by 1. So given these three examples, you notice that all the constants, or rather the scalar, I have already highlighted. So therefore, if I want to find the derivative for the first functions here, since I use a y, so I'm going to write it as dy dx. So I bring down the power, which is 3. So 3, I bring it down. The scalar is 20, so I just multiply them together. So I just leave the 20 alone, but I multiply with the 3. So it's 20 times 3. And then my index subtract by 1. So therefore, the derivative, this will give me 60x squared. Now let's take a look at the second example. Over here, what I have is a pi. Pi, it is also known as a constant. So by applying the power rule, so what I'm going to have, dy dx, I will have 3 pi x to the power of 2. Now how about the next one? This is y equals to 3 over x. Earlier on, I have shown you what is the derivative of 1 over x. So in this case, all I need to do is I simply leave the 3 alone. So when I combine it together with what I've done earlier on, so this will simply give me negative 3 over x squared. So this is a basic scalar multiple rule that all of you need to know. Now, how about the other one? So there's also this rule called the addition and subtraction rule. So the formula looks complicated, so but simply means, to find a function like this, I just need to differentiate each term one at a time. So what does that mean? So say I have a function like this, which is what you see at the thumbnail at the start. So I have 3 functions over here. So what we are going to do is we are going to differentiate this term, one at a time. So the first term here, I already have the answers, which is over here. Now let's take a look at the middle term. The middle term is cube root of x. So if I'm going to take a look, I rewrite this as index form. I have x to the power of 1/3. So if I'm going to apply power rule, so which means this term here, the derivative will give me 1/3 x to the power of negative 2/3. Now how about the last one? Last one, square root of 2. You realize that this is a constant. So since this is a constant, so therefore when I differentiate, this will give us 0. So by putting all this together, I will have the derivative equals to negative 3 over x squared plus 1/3 x to the power of negative 2/3. Very good. Now that all of us have the basic of power rule, let us use this to find the derivative of a more complicated examples over here. Now, the first thing that I would like all of you to take note is this term here, this phrase with respect to t. Now, earlier in the video, I mentioned the terms with respect to x. Right over here, you notice because it is with respect to t, so therefore what I will want to bring to your attention is that all the expressions here are written in terms of t. So that is the first thing that I would like all of you to pay attention to. Now, with that, let us see how we can find the derivative of these three questions. Now, do bear in mind, I'm going to tell you that I am not going to use quotient rule, product rule, or even chain rule. No need. Right? Often students see part A, these questions involve fractions, and very quickly they jump in and to say that, oh, they need to apply quotient rule over here. Likewise for part B, and they say that, oh, there are two products, right? There's a product of two terms. So therefore, very quickly, they will just apply product rule. And likewise for the last term, right, because they see there's a power there. So very often students will just jump in to apply chain rule. So over here, I'm telling you, I do not need to use quotient rule, product rule, and chain rule at all. Right? So what is the tip that I'm going to share with you? I only have one word for all of us here. All right, if we understand the problem, all we need is to always ask ourselves, can we simplify the expression? So remember, always simplify and simplify. All right. The moment you can simplify the expression sometimes, right, to solve and to find the derivative is actually a lot easier. So what do I mean? So let's take a look at the first question, which is part A. Now, if you take a look at the expression, right, it is a fraction, but this fraction I can simplify. How? I can actually simplify and divide it into three terms. So to do that, I just simply take 3t squared divided by square root of t. Likewise, I do the same for the second term and the last term too. To do this, I will be able to derive y equals to 3t to the power 3 over 2 minus t plus 6 square root of t. And once I have this, are you able to apply power rule to differentiate and find the derivative? We can. Now let's take a look at part B. Now part B is a product of two terms. Now over here, if you make an observation, right, you notice that I do not need to use product rule. Basically what I'm going to do is I just simply apply the rainbow method. So by using rainbow method, I multiply each term, all right, together, and I will be able to get, all right, t to the power 5 minus t cubed plus 2t squared minus 2. And once I derive to this term, I will be able to find the derivative very easily using power rule. Now, how about the last one? So it's the same thing, all right, similar to part B, right? It is to the power of 2 is a square, so I can simply just apply rainbow method and I expand this term, I will be able to get, right, terms like this. All right, so with this, I will be able to just apply power rule to find the derivative. So always remember, before you actually jump in to apply quotient rule, product rule, or chain rule, always ask yourself, am I able to simplify the expression? And I apply power rule and you'll be able to find the derivative very easily. So I will leave the answers here for you. All right, so do let me know what do you get over here for answers part A, part B, and part C. All right, do let me know your answers in the comment below. Hope you find this video useful. Do look out for my next video, which is on chain rule. All right, so if you like the video, do like and subscribe and share it with your friends. I will see you in my next video. Bye.